Good afternoon, everyone, and welcome to Layer by Layer, the show about 3D printing and our place here at Slant 3D inside of the industry. Today we're going to be talking about shipping printers to Ukraine, 1 million printers shipped last quarter, and military orders going around. But before we get into that, let's go ahead and pay the bills. This video is done sponsored by Audible. If you love books but can't find the time to read, Audible is your go-to solution. With thousands of audiobooks and podcasts, you can listen to your favorite stories anywhere and anytime. And here's the best part. By using our sponsored link down in the bio, you get an exclusive 30-day free trial, plus 1 free audiobook credit, and 2 credits if you're already a Prime member. So why wait? Give Audible a listen today. Now let's get into the video. Okay. So, 3D printing news. Bamboo Labs driving market dominance on entry-level 3D printers. From Context. This is from 3D printing industry. So, this report recently came out from Context around the overall 3D printing market and the numbers from last quarter. And it has been, it's very eye-opening in a number of different ways. That being said, there's a few interesting stats that I want to go through. Number 1, industrial 3D printers face falling shipments. Industrial printers costing more than $100,000 accounted for just over 50% of all global systems revenues in 2023. However, these global shipments of these printers dropped by 13% compared to 2022. So, this is... Number 1, this is interesting because regardless of how large the consumer 3D printing market is, it is only half of the total industry. And right now the industry is valued between $10 to $15 billion, depending on who you're talking to. So most printers are still from the big industrial guys, these really expensive systems. It is not desktop or small machines. So that's just an interesting note. That being said, however, the whole entire industry has pretty much taken a hit over the last year. There's a few places where it's grown, but not grown a lot. So like metal printers increased by 4% year over year, mainly DED type systems, and a few other areas grew, but they were all single digit growth, which is not typical of 3D printing, which historically has been around the 20 to 25% growth rate. But that being said, the thing that was most interesting and most highly defined, wait a second, before we get to consumer market here, we just did the industrial $100,000 units. The next tier down is the $2,000 to $20,000 machines. They also saw shipments decline over the last year. So the big systems decreased by 13%. The smaller systems have decreased by 33%. So the Ultimakers, the MakerBots, which is also technically Ultimaker now. But all of these premium-esque machines that are like $5,000 or $10,000 have had a real hit over the last year. A 33% hit is huge. That is an enormous drop. Everyone is attributing it to interest rates, being that these expensive systems are dropping off because they're a capital investment that getting a loan for is really expensive to do right now. And quite frankly, probably will be for some time. But it's hurt all of these expensive systems. Every professional 3D printer manufacturer in the global top 10, except Nexa 3D, shipped fewer units in 2023 than in 2022. That is interesting. This report, the Context report, has done a lot through surveys and that kind of thing, so they can actually attribute numbers to certain companies, though companies don't have to say exactly what it is. Anyhow, those small, low-range, higher-end machines fell precipitously in the last year. That can be attributed, yes, to interest rates, but also just to the rise of machines like Bamboo Labs machines and even the new versions of the Prusas. They're so good that those upper-tier machines just aren't really useful. I mean, a Bamboo Lab machine is quite good, or a similar style of machine. Up from that, the 20 to 100K one grew 16%, but wait. Hold on. There's something wrong with this note. In Q1 2023, they fell 7% year over year. Wait a second. Those shipments of mid-range machines they fell 7% year over year. I don't even know what that means. The large tier machines dropped by 7%. So if it was a really expensive machine, it dropped by 7%. If it was a pretty expensive machine, it dropped by 16%. And if it was a cheap, expensive machine, it dropped by 33%. So then that's a kind of the lower tier coming up to eat stuff, very, very likely. Because these are the interesting numbers now. Q3 2024 saw a new record high for the number of entry-level 3D printers shipped in a single quarter, with a figure of 993,000. Creality impressed with 38% growth year over year in Q4 2023. However, Bamboo Lab stood out with a staggering 3,000% growth year over year in shipments. 3,000, 30x increase in shipments year over year. Now, 2023 was the year of Bamboo Lab. 2022 was kind of the year of them proving themselves out and coming to exist. And 3033 was when they truly existed. Was it Kickstarter in 2022? I believe it was in 2022. It might have been 2021, and then 2022 was deliveries and like ramp up. And then 2023 was their year of shine. Not surprising, though. Their unit growth year over year most certainly would have been huge because they were ready to go. And then with the introduction of the A1 and everything else, they hit every mark along the way. Because from an execution standpoint, we've talked about Bamboo Labs. I think explicitly on this channel, we've done a video about them before, which is odd for us because we don't talk about printers. But from a business context, Bamboo Labs is a very well-run organization that demands a Harvard Business Review case study in many ways because it's just impressive to scale hardware that way. That all being said, 1 million printers shipped last quarter. By the way, this is an interesting number because I believe it was like 2018, 2019 when 1 million printers ever had been shipped. Like in the whole history up to like 2018, only 1 million machines had ever been shipped. And I think that it didn't accelerate much until 2020, where it really broke loose again. And then here again, we're at this point where we're like doing 4 million printers per year, evidently, give or take. It's more like 3.5, but because Christmas, it's Q4. And with low-cost machines, they can be gifted reasonably to a lot of people. And since they're eating into the upper end of the market, people would buy 3 or 5 Bamboo Labs machines rather than buying a really expensive Ultimaker. So it's brutal out there because this is a particular point of churn. But the other part of this, of those 1 million printers, once they are excluded from Q4, shipment growth in this price class falls from 35% to just 2%. So Creality and Bamboo drove most of the growth in this category, and they also control most of the volume in this category. I think even like Creality ships the most machines of anybody. I think they're literally, there was a report on them. I think they ship 500,000 to 1 million machines a year themselves. Like they're a huge component of it all. But all the other lower level ones are actually kind of hurting to where there's not really been growth in low level machines. So Creality and Bamboo Lab obviously because they're a high speed machine and everything. And then Creality because they followed up quickly and also have the means of distribution, were both able to grow within that. Once they're excluded, the rest of them only grew by about 2%. So the rest of the entry-level market, so your Anycubics, those kind of guys, only grew by about 2%, which is not a lot. That's just general cooling of the market. What will be interesting within this number to see that, okay, yes, nobody else had the technological advantage that like Creality and Bamboo Lab were able to leverage, but there's also the incestuousness of the 3D printing industry. I will be interested to see if all of the growth of like a Bamboo Lab, how many of them are previous 3D printing users and how many of them are new 3D printing users. I'm going to bet that a bunch of them were previous printing hobbyists. I think that this is the market like cycling. Like, all these Prusa guys swapped over or something along those lines. So this report next year will be fascinating. Companies like Toybox experienced a 51% decline in unit shipments, which is brutal. Overall, there's a conservative outlook for 2024. Context estimates only about single-digit growth in printers overall there. Single-digit growth in 2024. This is forecast to increase to double-digit growth by 2025. They don't give a reason for this, except that the pent-up demand seen on the horizon can be pulled into 2024. Pent-up demand for 3D printing. That's the expectation that people are holding back purchases this year because of interest rates, and then those will break loose in subsequent years. Might happen, might not. Personally, I don't really see interest rates declining at any given time. Okay, let's see here. Year over year. Entry-level shipments rose by 19% year over year, with global inflation expanding the market base for those more affordable 3D printers. This was the other thing I wanted to discuss. Chinese vendors are dominating this market, producing 94% of the entry-level 3D printers shipped in 2023, up from 88% in 2019. 2019 is an interesting year to pick, but yes, the Chinese market has dominated entry-level 3D and low-cost 3D printers since frickin' 2016, 2017. This is fascinating because in the context of units sold in comparison to a company like Prusa, you have 1 million machines, 94% of them, so 940,000 of them are there, 60,000 are from other people. Yes, I'm not losing my mind. Yes, 60,000 of them from other people. Quite frankly, the vast majority of the non-Chinese machines would be Prusa. So if you want to reverse engineer from that, if Prusa is selling 60,000 machines and they each cost whatever they happen to cost and so on and so forth, you can pretty much get Prusa's revenue for last year. And that's highly indicative of what it might be. 60,000 machines, and we'll say $1,000 per machine for nice round numbers. I mean, that's fine. That's good money. That's good money. No one should whine about that and that kind of stuff. But comparatively, and unit volume-wise, Prusa is not coming up from behind or maintaining, especially right now where I would say that the general market has a presumption of high competitiveness over there to where Prusa might be slightly on its heels. But anyhow, it's an interesting dynamic, and most certainly, yes, China has all this stuff. But as a U.S. citizen, I'm disappointed that we don't even really show up. We don't. Like, it is, it's disappointing in that context that 3D printing is something that pretty much passed my country by in a lot of different ways. Sure, we invented it, Stratasys and 3D systems and that kind of thing. But the fact that none of it carried through into these parts of the market that are, I mean, consumer printing is half of the market. The U.S. owns the upper half of the market, the expensive machines. Well, no, not Stratasys 3D Systems. Oh, never mind. No, they're not even both U.S. companies. They're entirely U.S. companies. But anyhow, side note, Stratasys, yeah. No, never mind. I'm incorrect about that. That all being said, yes, the U.S. has not been in on this and gaining on this. And you're like, oh, yes, the Chinese make stepper motors for cheaper. And yes, that's true. But quite frankly, the import of those low-cost components did not preclude the U.S. from it. We had 3D printing companies like MakerBot, Lulzbot, so on and so forth. And for some reason, didn't eat it, didn't take it on in any sort of way. I think so far in this conversation, I've been fairly non-disparaging and fairly factual in the things. I'm going to stay that way because, I don't know, people can say whatever they want about us too, so might as well. Okay, next piece of news. Internationally recognized KVG, an internationally recognized provider of mission support and logistics to the defense industry, has invested in 15 Nexa 3D high-speed extrusion 3D printers. It comes just months after HSE 3D printing solutions will be delivered to Ukraine as it continues to defend itself from Russian invasion. So 15 Nexa 3D printers, previously Essentium high-speed extrusion printers, are being shipped to Ukraine. The reason this story was pulled out and the reason I wanted to talk about this story is because this was very predictable. Nexa 3D acquired Essentium largely because of Essentium's connections within the defense industry. Essentium has long been a provider of materials and prepping for machines inside of the defense industry. And I would say that the acquisition of them by Nexa was to break into that, because getting in a rhythm of trust with defense contracts takes a while. When you first do the first ones, you're allowed to get up to $100,000 and you don't need like pre-approval and that kind of thing. But when you start getting into big contracts, which each one of these machines is, I believe, more than that. I don't know what the high-speed systems cost, but I think it's more than that. Those more expensive things require approval from the general and the acquisition and logistics guy and so on and so forth, to where it's a set of relationships that you can't simply show up at and say, hey, we're going to sell you printers. You guys want some printers? It just doesn't work that way. So the strategy of the acquisition between Nexa 3D and Essentium is bearing fruit right here, to where they're able to deploy systems to Ukraine. Interesting note, I believe that we applied for a contract for deploying printers over in Ukraine and their logistical advantages in the situation, based on a project that we had worked on a few years ago about print farms and shipping containers. But anyhow, Chinese manufacturers still have some catching up to do when it comes to the application on additive manufacturing. The new Anisoprint CEO gave his perspective on the 3D printing market in China on the latest episode of the Additive Insight podcast. Competitor, don't listen to them, even though there's only like 3 3D printing podcasts, so I guess go listen to them because they're like the other ones. Liu has appointed to the role of Anisoprint CEO earlier this year, with founder Fedor Antonov transitioning to the role of CTO. The company has moved its headquarters to Shanghai a year after opening its Shanghai office. It has positioned itself as an early mover when it comes to composite 3D printing in China, but concedes its new domestic market still has some maturing to do. So the market in China is theoretically huge, Liu said, but if you look at industrial 3D printing, the market mostly goes to North America and Europe. The understanding of how to use this technology, most of the Chinese manufacturers are still behind. The good news is that the market's catching up. Our top priority is still focusing on the global market because it requires much less effort to educate the market. You just have to deliver a good solution. This is fascinating. At the consumer level, China obliterates everybody. At the professional level, China itself does not use 3D printing as readily as other industries are. And it's an interesting situation that there's so much strength in one area of it and so much weakness in the other. There's not demand for the large, expensive systems over there. The danger of this is that those lower grade consumer machines keep on improving, like Bamboo Labs has demonstrated, and come up from behind. That's, given the fact what a lot of these expensive systems are focused on metals and composites and that kind of thing, that's kind of unlikely, because there's just weirdness in the production of those materials to where it's like, oh, we're going to make a desktop concrete printer. No, you're not. It's got to be the size of a house because concrete doesn't flow through a tiny tube. That kind of a thing. There's just technical, physical challenges with some of this stuff. But in the context of the U.S. getting back on its horse and catching up with all this stuff, using printing over here more than other places is interesting. Part of that, I would believe, is also because we have a more robust aerospace industry than like Asia does. Because we build planes and we have Boeing, and yes, Boeing comment, but Boeing, Lockheed, so on and so forth, where printing was adopted very early in very lucrative industries, to where the higher end utilization of 3D printing was very evident very early on because of these very technical, hard tech industries that we have. So adoption of 3D printing was very early in those spaces, whereas manufacturing of low-cost goods was not very popular in the United States to create sustainable companies out of it. But that's interesting set of news this week. It's a really interesting set of news this week. The context report and the rest of it, I highly recommend reading the full story over on the 3D printing industry. Bamboo Lab driving market dominance on entry-level 3D printers. Context reports. Look, check out the context report. It's really good. Okay. Product updates and things. Software. Etsy app, API, and other things coming down the pipe. The API is up and everything else. The stability over there has improved. Our new server has been working well. Good job to the team on all that kind of stuff. But yes, that's all been running well. It appears everybody's been testing all right and doing okay. No, I don't have anything to say about that. I don't have any other really announcements about it. It's going well. Check it out. I do recommend it. There are upgrades to the Etsy coming pretty darn soon that I am quite excited about. We're excited about that. But those will probably be announced about next week, I would imagine. Tangled is getting into a rhythm. We're getting rolling. We're getting ramped back up here after the whole snafu at the beginning of the year. So it's getting into a better and better spot. We're working on getting the new extruder for Tangled itself integrated, which is just calling a bunch of electricians and other transformers and all those things. It's a joy. It's a joy, I'll tell you. Nothing like budgeting for expensive stuff. Anyhow. But yeah, Tangled is continuing to get ramped up, and we want to push that a little bit more. We're working on trying to get some additional partnerships on there as far as like the Gillette filament and stuff. Oh yeah, I think there's Gillette wood filament over there right now. If you stock us for whatever that stuff is, so tangledfilament.com. Yes, I think there's Gillette wood filament from a project that was incomplete that we have left over. So I think that stuff goes for $15 a kilogram. The team picks different prices depending on what the course. We're not going to sell carbon fiber nylon for $15 a spool. Sorry, guys. But yeah, most of the stuff it has its individual pricing. I think I think it's PLA wood should be about $15. Tangled testing. Okay, yes, update on Tangled testing. We ordered the machine about 2 months ago. It is on a boat right now, about to land in Portland, Oregon. That's the update. I am not excited about this at all, guys, because international import of something like this. This is a very custom piece of equipment with a very specialized company and that kind of thing that doesn't do regular international shipping. We work with a lot of folks for international shipping often, and generally it is quite seamless to import certain things. But some things are not. And this thing has not been seamless. The import of the tensile testing rig, there's so many new layers of import paperwork that I've forgotten about because, quite frankly, many of our suppliers are just better at importing things. But it's an experience thing. It's one small company sending stuff to, frankly, another small company. We're not going to have 12 people standing around who are like, oh, what are the ISF documents for this or whatever it was. So the import fees just keep on adding up and adding up and adding up to where, my goodness, are we going to sell out so fast when we start making so many of these videos, guys, because we got to get some money rolling through this. By the way, the Kickstarter did not cover the cost of that machine, for the record. We fully ponied up a lot in order to get this landed. But we still think it's really, really important because Tangled testing, getting quantification of 3D printing design parameters and 3D printing slicing profiles and materials is really necessary. And quite frankly, I'm excited to do it. We have a number of sponsors lined up for the Tangled testing channel that we will start breaking loose. We've been working through video formats, and yeah, you guys have seen a number of the experimental videos over there as we've been figuring it out and getting it lined out. We're both gonna test all the materials and everything else, run through all of the print settings and so on, all the typical things. But we're also gonna try to push more non-material related stuff through there as well. So like we have a video coming up that's a design for video, but it's an improving strength video through a particular feature of a printed part. and that will be paired with a Tangled testing video that provides a bunch of the data in the Tangled testing video, but then we can pull that data in a less boring format into the main Slant 3D channel. So it's going to be a fun video because the solution, quite frankly, is really cool, and I'm excited to share it with you all. It's really good about the for the reinforcement of 3D printed parts. So stay tuned for that. But yes, Tangled testing is certainly still on the docket. And yes, we still all owe you 20 videos for the Kickstarter on those. So we will get those all out. But we're getting it lined up and getting it rolling, while at the same time attempting to maintain the production schedule over here. So yeah, Tangled testing is doing fine and cranking right along. Other product announcements. Tangled testing. Whew, wow, we work on a bunch of stuff. Internally, we've been focusing on a lot of projects internally here as far as ramping up stuff. Both client projects, because number one, we got to keep our clients happy. That's how we exist. That's what keeps the ring light on. That's what shipping the parts that we're supposed to ship. And yeah, the clients pay the bills. They get priority over everything else. But there's a number of internal projects coming out that we haven't really discussed, but we will probably dig into them on podcasts a little bit more. But one of the projects that is being deployed actually this week is Kraken and Starfish. And they're pretty sick. Like they are very useful for continuing to expand the scale of our already quite large print farms. And yes, the Austin factory wheels are starting to turn here, so we'll start having updates with that soon. Maybe some cool selfie video vlog stuff coming through pretty soon, as that space gets ramped up. Okay, I believe that's all of the updates for this week. Let's see. I think we got all of them. Yeah, there'll be some. Never mind, I'm not going down that road. Okay, that's fine. That'll have to hang in the air. All right. Discussion topic, food safe 3D printing. Oh no. So, let me tell you a thing. Food safe 3D printing. We've been working on a video about this for like a year, working to write a video about food safe 3D printing for almost a year. It was like one of the first 10 ideas of like, what's the video we should really make? Food safe 3D printing. Yep, that's the one. The problem is that food safe is so contextual. Here's the thing. Anybody who says 3D printing is not food safe, you're wrong. And anybody who says 3D printing is food safe, you're wrong. So okay, let's add color to this black and white situation. 3D printing materials. There are many food safe 3D printing materials. And in fact, implicitly, fundamentally, almost every single plastic that is printed is food safe. Even PLA. Like all of them are cleanable and fine. And if you need look no further for a comparison than wooden cutting boards. Oh yeah, let's fillet a fish on this knotty piece of pine and that's been stabbed by a knife for years and years, and then let's just wash that off with water and soap and it'll be fine. And it is. People are not dying of E. coli from fish or whatever it was all the time. That's perfectly fine because, first of all, humans are quite robust. And so long as you do wash stuff and don't just lick a puddle of fish blood off of a cutting board, you're fine. And then try to shave up some cabbage afterwards, you're okay. So the 3D printing can absolutely make food safe products, and there's all kinds of food safe products where it's feasible. I mean, things like cookie cutters that are kind of a dry interaction are fine, and then you rinse them off with water exactly the same way you would a cutting board. We have a video that might, I think, will be released before this podcast comes out around a coffee maker. You should go watch that one. It's a good video. It's a really good design. I enjoyed it. But that video was awfully good. There's a lot of places you can build a lunchbox with 3D printed parts, all these things that come in contact with food. 3D printed parts can absolutely come in contact with food on a regular basis in all kinds of different ways. Generally with 3D printed parts, when coming in contact with raw foods, it is not recommended. The reason for that is because while materials like wood are very porous and absorb a lot of nastiness that most certainly is not washed off with soap and water. 3D printed parts, especially if they are not fully solid, if they have an infill, are so porous that you do create effectively little petri dishes inside of the part. Basically, each cell of infill could fill up with the animal matter and rot or grow something, which is not desirable in any sort of fashion. So it is very important to both design appropriately for food-safe applications and understand the food-safe application. There's the component of like waterproof and that kind of stuff. If like you don't really want to make a 3D printed FDM water pitcher, it can be done, and quite frankly, it is quite reliable anymore. But it's not, in our case of mass production, it's not reliable into large-scale production. You can make something water-resistant, absolutely. Making something fully waterproof is exceptionally difficult because you have 1,000 tool moves that all have to be perfectly waterproof in order to achieve that. Without coming from a homogeneous component to an anisotropic component, it is very difficult to make it waterproof. There's lots of ways of getting it done, but that's a separate topic. If you cannot make it waterproof, it's very tough to seal it against germs. But at the same time, if it's not waterproof but water resistant, it's also tough to purge the germs because they soak into it. That all being said, I am generally of the mind that for most baking applications and most home applications, 3D printing is fine. You can make a salad bowl. You can make a fruit salad bowl. You can make measuring cups, coffee mugs, not coffee mugs, but coffee koozies, all kinds of things. People can drink out of or eat out of a 3D printed component easily. Like when we did 3D printed spoon, that's totally legitimate. It would be fine. That's a perfectly decent food safe component. There are a number so in general, 3D printing can very often make very many parts and pieces that can be used for food applications. It's fine. There are a few myths in this that I would like to debunk because I've seen them brought up and they're ridiculous. One of the first ones is lead in the nozzles, which is some conspiracy theory from 2012 that is even then a stretch. The theory goes is that brass nozzles use small amounts of lead inside of them in order to make them a little bit softer, and therefore that lead can leach into the filament as you're printing your cup. Few problems with this. The first of which is that I don't know of anybody who actually, if you found anybody who actually broke down one of those nozzles and said, lead content way too high, happy to hear from it. That being said, I'm pretty sure I would go and lick a part that was printed with a fully lead nozzle because the amount of lead that could be leached into it would be so fantastically small. Because if you just think about it of like, okay, the outer outline of the nozzle is pure lead, fine. As it's flowing through, it's only the outer skin of it that contacts the lead. The vast majority of the filament coming out has no lead in contact with it at all. It is a tiny percentage of a tiny percentage. And then there's just the question of the amount of lead that nozzle could possibly leach into you. It doesn't take much lead to be bad for you, but it takes a lot more than a non-lead nozzle could possibly ever ooze into whatever the part was. You could drink a lot of cups of coffee before you could drink coffee out of a lead mug for years and you wouldn't know. I'm not recommended this, and lead is bad, and don't be stupid and that kind of thing. But the fear of lead in 3D printed parts is ridiculous. And then there's like the conversation of like, oh, the extruders that were making filament are lead lined or whatever else it was, which is also ridiculous because that's just a completely non-functional piece of industrial equipment because it's too soft. They're made of hardened steel. There's no way that lead could possibly come in contact with them. That entire conversation is silly. There is also the conversation of like, oh, certain plastics aren't food safe. Oh, you can't use wood PLA for food safe products. Yes, you can. Literally almost any product, any material is food safe. Can be food safe. Let me say that. That's better. I feel like I'm walking around the edge here. I'm not trying to peddle something. It's just, I don't know what all. But 3D printed parts, the materials available can all be food safe. As far as actual food safety, the certification for a food safe product, you can register a product with the FDA. Most products do not have to have the FDA registration. There are many, many products that are general use that do not require FDA certification in any sort of way. And quite frankly, if you're anything short of medical device, you don't really need FDA certification. So you can go make measuring cups however you want. And so long as nobody dies of lead poisoning from your measuring cups, no one's going to care. Functionally. The materials that there are materials that have been approved for certain applications. So if you use that material, that's a good proxy to actually certifying the particular part. And I got to make sure that I don't confuse child safe with food safe here, because I'm going to start overlapping those two certifications. But food safe, yes, food safe is pretty much open season. Don't be stupid. Don't make a lead coffee mug, and most of the time you'll be fine. Plastic components, as far as PLA and the rest of it, are completely acceptable and fine. And as far as mold growing on them or something like that, mold grows on everything. Mold grows in the bottom of Stanley Yeti cups. Can you get sued? Yes, we live in America. Everybody can get sued all the time for everything. So crumple up and die and never make anything, I suppose. But the probability of being sued, hashtag not a lawyer, is low. So long as you're being responsible and doing not stupid things. But making a food safe 3D printed part is not a stupid thing. It's perfectly reasonable to make a food safe 3D printed part. And there's a lot of applications where it's totally fine and works just fine, even with the design limitations of 3D printing by the nature of the process. You can make a flay board from 3D printing that can be perfectly food safe. It's totally doable. You have to be intentional about how you do it, and there's ways of ensuring that it is as safe as it can possibly be. But achieving that is not impossible by any means. And making food safe 3D printed parts is absolutely a thing. And yes, one of these days we will go through a video where hopefully we can lay that all out in potentially a more cogent manner than normal discussion. But going through all the certifications and all the edge cases, the very fact that it's not really a certification. It's like, don't make something lead. Cool. Then you're pretty much good. But then as far as your level of comfort with the safety of the product, of like, what is the microbial buildup of this part over time, that's very often left to the discretion of the company, for better or for worse. But yeah, there's just those sort of things to be done there. Okay, that's pretty much it. We had another discussion topic, but we'll probably save that one for a different time. Thank you all for listening. If you made it this far, comment down below with any sorts of topics that you'd like to have us cover, or anything that you'd like us to dig into a little bit more, and we'll be happy to go into them. But other than that, have a great day, everybody.